This question is very similar to the previous question, so you may want to watch that first. It says, consider the reaction below at a certain temperature and pressure. The reaction begins with only PbO of zero point 0.1, that should say molar, and O2 at zero point 0.2 molar. And the equilibrium constant Kc is 9.81 times 10 to the minus 6. What is the equilibrium concentration of PbO2? So this is kind of a strange reaction because we have lead oxide compounds of lead 2 oxide in the gas phase, but at a high temperature, I guess it's possible. So let's take a look at this. So we're again going to need this ice table, okay? And this is very similar to the previous one. So the initial concentration of the PbO is 0.10 molar. All right, the initial concentration of the O2 is 0.200 molar, and the initial concentration of PbO2 is 0 molar. All right, because the reaction only begins with reactants, there is no PbO2 at initially. Change. In this case, we don't know the concentration of this, but we know that we're going to get 2x. Why 2x? Because there's a 2 here. We also know we're going to lose 2x of this, and we're going to lose x of this. So the stoichiometric coefficient goes with the x. So at equilibrium, the concentration of PbO is going to be 0.100 minus 2x. The concentration of O2 is going to be 0.200 minus x, and the concentration of PbO2 is going to be 2x. Now we have all of the things that we need in order to set up the Kc expression. That being said, we're going to, just like in the previous example, ignore x. In the previous example, it turned out that x was about 8%. So if it's less than 10%, we can ignore it. Or generally speaking, we're not going to use the quadratic equation in these examples or the examples on the randomized online homework. So let's take a look at how we might do this. So the Kc expression is going to be products over reactants. In this case, our product is PbO2, and there's two of them, so that's squared. Our first reactant is PbO, which is going to be squared because there's two of them, and our second reactant is O2, which is not going to be squared. Now, we know the value of Kc, it's given in the problem. So 9.81 times 10 to the minus 6 equals, the equilibrium concentration of PbO2 is 2x squared. The equilibrium concentration of this, PbO, we're going to ignore the x, is 0.100 squared. And for O2, it's 0.200. So you're going to multiply this times this squared times this, and you're going to take 2x and square it. 2x squared gives you 4x squared. You have to square, sorry, can't see that. You have to square the 2 and the x, so you get 4x squared equals this times this squared times this. All that together gives us 1.96 times 10 to the minus 8. Divide both sides by 4, and you find that x squared is equal to 4.91 times 10 to the minus 9. Take the square root, and you find that x, or the equilibrium concentration of PbO2, is going to be 7.00 times 10 to the minus 5. Now, if you want the actual equilibrium concentration of PbO2, it's double of this. It's 2x. So it's going to be 1.40 times 10 to the minus 4. You have to double this because this is x, and the concentration of PbO2 is 2x. So just that times 2.